recording now, Garry. So now
Okay.
can you explain how the product
Right.
works?
So the way I explained it when I was up there, and this is where the health practitioners really could see the benefit, was I concentrated on the hypothalamus and how its main priorities were survival. This is your survival brain, your primitive brain, survival brain. And if you sort of want to see it in action, try holding your breath. Mm-hmm. And you try and hold it for more than a minute or 2 minutes, and suddenly it'll just activate every part of your body to get you to breathe again. So it's actually very powerful in how it operates with your body. But it has, the priorities are survival, maintenance, and then repair and rejuvenation. And if you sort of put it on the pivotal where maintenance, it sort of always keeps at maintenance level. But when it's out of balance, it puts priority to survival. So suddenly it goes sort of like that. So survival takes priority. You've got minimum maintenance, so the body's not under threat, but it puts repair and rejuvenation last. And that's what's happening under stress. And that doesn't matter whether you're overweight, because what the main threats, if you go back to the if you go back to 10,000 years ago, and our main threats were starvation,
Yes.
Disease,
Yep.
and predators.
Yep.
Now, the way it protected itself against starvation was actually it stored fat. So if it felt that there was a threat to the nutrition or what it could eat, it then put a priority on storing fat.
Yep.
Now, actually, in a way, we had better control over starvation. We had ways that we could actually maintain our food supply.
Yep.
But we didn't over disease.
Yes.
So really disease does actually have a very high priority, because that's something we had no control over in a way.
Yep.
So what the body designed to protect itself, as soon as there was some sort of toxin or something, some sort of inflammation, it immediately surrounded it with fat.
Yes.
So it would actually be trapped. It created a prison of fat.
Yep.
If it was a predator, its reaction was, well, I'd have to be lean because I have to outrun that predator.
Yes. Yeah.
So the first two store fat, the last one sheds fat. But either way, if you're still under stress, and its interpretation is that you're under threat from a predator, and its interpretation, like a corporate ladder or struggling to maintain your job, is seen as a threat as a predator. Either way, you can be really skinny or really fat. Your hypothalamus has put survival as the first priority. And what happens is your rejuvenation, your overall long-term health is what suffers.
Yes.
So what this program is about, that very signal it starts, this is all controlled by the leptin signal.
Yes.
It's the one that actually, the master hormone that signals the hypothalamus to react in this manner. Under the constant threat that we have with the lack of the micronutrients, glyconutrients, and even some of the major nutrients, like the omega-3, is that it's in constant survival mode. It becomes the default setting. The other thing, you can be really skinny, but it still has this default setting of survival. And what happens when you're in that situation is it develops leptin resistance. It ignores totally the signals, the regulator that leptin would normally provide, because it's in survival mode. It says, I have to protect you. Your hypothalamus and the leptin signal is your survival signal. So it's there to protect you, to make sure you're alive tomorrow. So it just says, I'll ignore every other message and just say, we're in survival mode. But what this program is about is actually changing this back to this level here, because on a day-to-day basis, this should seesaw up and down.
Yes.
And if you think about it, again, how we evolved,
yes,
we'd go out to go and gather food, and we'd be under threat. There would be threats there. So our brain actually is set up to actually become very active and alert first thing in the morning. And there is your cortisol levels rise.
Yes.
So they're your fight and flight ones.
Yes.
So you're ready for predators or some sort of danger during the day.
Yes.
While you're gathering food. So it would sort of go in a bit more survival mode.
Yes.
But that would then regulate, sort of come as you finish for the day and you're back into your cave or wherever wherever the community was,
yes,
it would then regulate.
Yes.
So be coming back to the normal. And then at night, it then was designed, because your cortisol levels would lower would then actually then put repair and rejuvenation
Yes.
as a priority at night.
Okay.
So it would balance
Yes.
regular during the day as opposed to where we are now.
Yes.
Those signals, the leptin signalling actually originates from the colon.
Yes.
And what scientists have found just recently is those receptors, GPR41 and 43. And this is where we're now getting into nanotechnology, because those receptors are at nano levels. They weren't able to discover them before because they didn't have the equipment or resources or the understanding to find about receptors. And receptors work off the infrared communication within the body. So they're not like we're used to the chemical ones where we've got different hormones giving signals. We're also used to the nerve one, which is sort of like, in a way, electrical impulses that give those messages. But we've never really been made aware of the infrared signalling. And that's where the cells get their instant communication from. And that's where the leptins, these molecular receptors, such as GPR41 and 43, come into play, because the signals originate from the colon, but they then go throughout all the receptors throughout the body, which then signal the cells to do certain things. So what happens with 41 is when it's turned on, it sends a signal out to all of the cells in the body to gather as much nutrition as you can and store it. And that's what starts the fat cycle. But the leptin signalling, because the 41 and 43, they're called the orphan pairs, because they've got a certain peculiarity as opposed to the other molecular receptors. 43 works in conjunction with it, and when 43 is turned off, the body will absorb a lot more inflammation.
Okay.
And when it absorbs the inflammation, it's the 43 that sends the signal out, start producing leptin. Because where the contradiction with leptin is the lower the leptin levels, the healthier you are. When it gets higher, then that's when it's saying to the body, start storing fat. Again, if we're going to go to pharmaceuticals, that's why you can't buy a pill for leptin, because it's going to give us the wrong message. You need a pill that says don't produce leptin. But that signal originates from the colon, from the GPR43. And that again is just a recent study that originally it was thought that the signal to produce leptin originated from your fat cells. It's not, it's from your immune system. And if you come back to the survival, that makes sense, because disease was one of our biggest killers.
Yes.
And something we really had no other defence from except the body producing fat in our survival, in how we evolved.
Yes.
So that's why it has such a high priority in the immune system. And 60% of our inflammation originates from the colon. So by tackling the colon health, we're actually activating the 43, reducing the amount of inflammation that's entering the body, and then we're also turning off the 41, so the communications to the cells are actually only taking as much as we want and don't take in any more.
Yep.
So the way that what's happened in our diet is that we're not giving the colon the nutrients it needs to actually create the right conditions for these to go into balance.
Yep.
And what it needs is the nutrients that will allow it to ferment, create a positive, beneficial fermentation.
Yes.
And that's what our product does. It actually it does several things, but one of the major ones is it gives the nutrients to the colon that it needs to get back into balance.
Yep.
It also actually has in it the micronutrients and the glyconutrients, which is absorbed in the upper digestive tract, because that's one of the things that's lacking in our foods is the micronutrients, and especially the micronutrients because of our farming techniques.
Yes.
It doesn't carry the levels of micronutrients what we eat will have contained in them, because it's just kept farmed and farmed and farmed. And these are very, very minute levels that we need.
Yes.
And also, again, how we evolved, we'd pick our fruits, our grasses, we'd eat it straight away, we wouldn't store it for any length of time. Because what we eat's got cellular structure, that cellulose structure hardens.
Yes.
You get the macronutrients, but it holds the micronutrients.
Yep. Okay.
So where our product is it's based on as well on spirulina, which actually holds all these micronutrients in its complex sugar structure.
Yes.
And that just dissolves and just immediately enters the body straight away. There's no cellular structure to hold or deprive us from those micronutrients.
Yeah.
Because it's also got the complex sugars, it also supplies the glyconutrients,
Yes.
which are essential for our cell communication as well.
And not that it matters, but where are the receptors in your body, like the 41, 43? Like in your brain or your heart?
No. This is where the telemides, and I'll actually practice the pronunciation of it.
Yes.
It's been described as a little tail, an antenna if you like.
Yes.
It's on each of our cells. So our cells have the mitochondria in the
Yes.
middle, which
Yes.
is the brain of the cell.
Yes.
It's the decision maker.
Yes.
It has this little tail, which is like an antenna.
Yes.
On each of these antennas, there's receptors that will only accept a certain signal. And it has some for chemicals, and it has some for these infrared signalling as well. So the receptor might accept only a particular wavelength, and when it receives that particular wavelength,
Yes.
it'll send that signal to the mitochondria to do certain things.
Okay.
And in this case, such as the power bands, actually when it's in leptin resistance mode, it will not accept a signal that says start producing energy. It'll only accept it in a very limited way because the priority of the body is to store fat
Yes.
and to lower your energy levels.
Yes.
So it's receiving a signal from the hypothalamus that says lower your energy levels and store as much fat as you can.
Yes. Yep.
And that's originating from the GPR43. And there'll be a receptor on this
Yeah.
for the 43 and the 41.
So in every cell in your body, you have these
These telemides.
telemides. Yes. Okay.
Now, as I say, there's that, as I was going along there. These telemides, though, as the cells reproduce, because they duplicate and they rejuvenate.
Yes.
And again, when you're in this mode, it's not rejuvenating correctly.
Yes.
But when they're rejuvenating, if they haven't got the right nutrients, the glyconutrients and the micronutrients, they won't reproduce correctly.
Yes.
So your antenna to receive certain things won't form properly,
Yes.
certain messages,
Yes.
and it won't receive, even if those messages are there, it won't receive them properly.
Yep.
Just to go back to about the infrared, that's what I was going to say about the infrared signalling. And I think I've said this before, but we're all used to the concept of this room's filled with white light,
Yes.
which we don't see. If I look at a particular colour, say the red or the pink of that cup over there, what's happening is that the white light, it's receiving the white light, which we don't see.
Yeah.
It's actually filtering everything else except the wavelengths of that light, that white light, to send back to the receptors in our eye to perceive it as red.
Okay.
Yes, hello.
And this is exactly what's happening with the body in this cell communication.
Yep.
In that the body is filled with infrared, and we know that because they've got even cameras now that can
Yes.
measure the infrared
Yes.
in our body.
Sure.
So we know our body's got infrared, but we can't see it.
Yes.
And we know it comes to the surface and it radiates out. That infrared contains a whole lot of wavelengths.
Yes.
And in fact, NASA use infrared signalling to guide their satellites now.
Yep.
And in fact, even they're exploring the universe through infrared now.
Yes.
Because it's much more penetrating and got a much greater wave accuracy in its
And
wavelengths.
even the military drones and all that. It's all
Yes,
infrared. Yeah.
it's all infrared.
Yeah.
So what the bands do is they absorb this free floating infrared the same way as that cup absorbs the free, just all the white light.
Yes.
It then absorbs everything and reflects back only the signal that says do this, perform this certain act.
Yeah.
The energy ones are sending one back that sends a message directly to the cells that says, and it's a strong message, it's a fairly strong message that says, or a specific message that says, actually start producing energy. I want you to now start producing energy.
Yes.
And it does. That's why you get an instant result
Yes.
with those tests, because it's not relying on hormones to filter the way through,
Yes.
and it's not even relying on the electrical impulse of the nervous system.
Yeah.
It's communicating directly to the cell. It's overriding the leptin resistance message
Yeah.
that says actually conserve energy.
Yeah.
So it sends that message directly to these receptors on your telemide.
Yep.
It then sends a straight a message to I'm getting myself, once I start using too many words, I get this mitochondria.
Yes.
It then sends a message within the cell that says, right, start producing energy now.
Yep.
And when you then put that throughout the whole body, you've got an accumulated effect that gets that result.
That's good. Yeah. That's